Hi everyone, my name is Misha Kogan, and I work at KCure. Let me tell you a little bit about KCure. So behind me is a kind of an official explanation about KCure. I'm going to give you like my version of it in a second. Before that, let me ask you, can you hear me? Because I usually speak not too loud without the mic. A little louder? Okay. Can you see the screen? Okay, perfect. So, we do e-discovery stuff. And what does it mean? Think about a hard drive and a bunch of stuff on the hard drive. What we do, we take data from the hard drive and process it. We process emails, Word documents, Excel files, wherever they can have metadata and text. The key here is the extracted text that we get. Then we do stuff with that extracted text. We act on it. We analyze it, we search it, we parse it, and we do some even artificial intelligence stuff with it. So really that text is the key for us. Our flagship product is Relativity. Relativity is mainly a review platform, but also has a bunch of other stuff you can do, like workflows, analytics, anything that litigation professionals need to review the cases. Now, here's how Relativity works. Say Google sues Oracle, the thing that happened some time ago. I'm not saying they use Relativity, but if they did, they would load all their documents from their case into the Relativity workspace. And then reviewers can log into Relativity and analyze those documents, review them. Lots of documents, millions of documents. At the end of the day, you might have a few, maybe 10, 20 documents that are relevant, and it's Relativity to the case. That's how you would find relevant documents. Relativity is pretty awesome. We even have an iPad app for kind of like top lawyers, so they could analyze their most important kind of like high-level documents wherever they are. Here's the agenda for today. We're going to talk about our challenge. What was the problem? How we solved it. We're trying to solve it with Elasticsearch. I'm going to do it right now. We're going to talk about how we blend Elasticsearch with SQL Server data for our audit data. And we're going to talk about that. Then we're going to talk about extracted text, how we blend that with SQL Server data. And then we're going to have, if we're going to have time, we're going to talk about user metrics, or how we track our users in real time. Now, I propose that we have questions in between those sections. If anyone disagrees, speak now. Good? Okay, cool. Awesome. So, let me tell you about our challenge. First, let me explain the types of data that we deal with. Okay. What do you guys think this is?
Notepad++.
Correct. It is. It is Notepad++. As a matter of fact, it has some data zoomed out all the way. And I'm going to just tell you guys. This is 10 lines of log records. Just 10 logs. Okay. And what do you think this is?
More logs.
No. This is also Notepad++. But this is FEN e-discovery documents. So just to show you the difference that we do not deal with logs, we deal with large unstructured information. And the average sizes of extracted text are between 2 to 5 kilobytes, with outliers going to 2 gigabytes. Now, you might ask, what the hell is 2 gigabytes of text? Think of a financial Excel spreadsheet with a bunch of numbers. You can get that text to be up to 2 gigabytes. Awesome. There's a lot of data that's generated every day, and it's growing every single day. Look at it, 294 billion emails sent every day. That's a lot of opportunity. This is my favorite definition of big data. it's really a bloated term, and many people use it differently. But it's really depends on your use case. For some people, 100 documents could be a lot of data. For some people, 1,000 documents could be a lot of data. Big data is really when amount of data becomes a problem. As I mentioned before, in relativity we have workspaces, so cases with documents. And we used to store all the data in SQL Server, right? I would say at about 1 million or 2 million documents in that case on the SQL Server database, that's where we started to see big data. Anyone here uses SQL Server in production? Cool. Anyone uses Elasticsearch in production? Have you guys been to the session about Elasticsearch? Oh, cool. So for those of you guys who deal with SQL Server, have you dealt with terabytes of data? Now, not relational data, not just binary blobs, but really textual data in a full text index, for example. Well, our clients dealt with that. And I gotta tell you, it's tough. It's tough. All this data that's sitting in the SQL Server, it really affects it. And you can't do much with it. I've seen clients loading up to like terabytes of RAM into their SQL servers just to handle 10, 20, 100 million records that are sitting in one table. And that extracted text is pretty much majority of the database. Let me explain a little bit about the cases and what it all means. So, as I mentioned before, with Workspace and Relativity, with a SQL Server database on a SQL Server servers. So you could have many cases and many databases. Now, you could also have many servers. So that's how we used to scale up. Now, if you look at each one of those databases, let me see if this works. Cool. Let's look at this database right here. So if that grows, and we project that case sizes will grow over time significantly. So if this becomes 500 million, we can't really do anything about that. And we tried. I'm gonna tell you about that in a sec. So we had a problem. We couldn't handle so much unstructured data in SQL Server. We have experimented with different technologies before going to Elasticsearch. We tried to kind of keep the data in SQL Server and kind of like redistribute it across. We tried to use Microsoft File Stream, custom files, and even separate tables. We ran some experiments, but nothing really worked. So our challenge was to find something that's going to help us to handle all this large data. Something that's going to scale. It's going to run on Windows. It's going to be easy to install. And it's going to run on the commodity hardware. We also wanted to find something that's going to have search capabilities. As an example here, so we're looking for something that potentially could be Lucene-based, as Lucene is one of the most popular technologies for searching. So guess what we found? Elasticsearch. Give it away. So we currently use Elasticsearch to store all that unstructured information. That can add up to about 75% of the total data we used to store in the SQL Server. In some cases, I've seen clients that have up to 98% of the database just text, and 2% just all the other relational data. Now, we did not get rid of SQL Server because SQL Server is great for relational data. So when reviewers review documents, they tag the documents. They say relevant or not relevant, and that tag goes into the SQL Server. So we decided to keep that data there, frequent data in SQL Server, and kind of unstructured or static data in Elasticsearch. Now, when I say static, what I mean is email is an email. Once you extract text from it, it doesn't really change. It only changes sometimes when we have error scenarios, basically edge cases. So what are the benefits of Elasticsearch? Well, the biggest benefit is that it's elastic. It can scale up. So SQL Server scales up. Elastic can scale up. You can start with a smaller case, maybe 1 million documents, and then over time that case can grow to 100 million, and Elastic really helps you to kind of scale dynamically. You could add more nodes, and the data will just kind of like dynamically spread out across those nodes. It will start working better for use case. Another thing that I wanted to mention, for those of you who are like in the SQL world and database world, backups is very important, your backup strategy. And what was happening before with all this unstructured information in SQL Server, people tried to back it up. There's just so much data, so they literally couldn't. So sometimes they would skip back up their data. Once we removed 75% of the data, now we could have more frequent backups for your frequent data, and we could still have backups for your unstructured information in Elasticsearch, since that allows us to do incremental backups. It's pretty awesome. So how did we use Elasticsearch? How did we plug it into our ecosystem? Well, first we built a library in .NET that kind of wrapped Elasticsearch. And we made it pluggable, so it not only can work with Elasticsearch, but can work with anything else, like a file system. So we did a proof of concept and made DataGrid work with a file system. Now, we built a couple of...
That's a question.
Go ahead.
Is Elasticsearch a proprietary program that is owned by Kura, or what?
No. So Elasticsearch, sorry I didn't mention it, it's a good question. Elasticsearch is an open source software. It is free to use, and it's owned by Elastic.co. They just renamed themselves. We built a couple of REST services for different things, and we're still in the process of building more things for whatever we need. And we have SQL Server data in play here for this API. So I'm going to jump into the demo in a second. For Elasticsearch, I'm going to show you how we use the DataGrid API, how we pump data into Elasticsearch. Before I do that, any questions about anything I said? Go ahead.
Kind of related, but have you guys explored Elasticsearch on like HDFS? Or are you using the native backend?
We did not. So we wanted something simple, and Elasticsearch just works in a regular file system. So that's what we use.
Gotcha. Thank you.
Sure. Any other questions? Cool. So I'm going to jump into Elasticsearch demo now, just to give you some kind of like guideline before that. I'm not going to do too much in-depth analysis of Elasticsearch. There is, I think, another talk today about Elasticsearch, so go ahead and learn about that. So this talk is really about blending Elasticsearch with SQL. So what we see here is Elasticsearch cluster. We've got three nodes on the left, a master node, and 2 data nodes. Now, what is the master node versus data node? So in this many distributed systems, you have this concept. Okay? The master node right here is kind of brains of the operation. It decides who will do work. And the data nodes are your scalable part. They do the hard work. They actually the muscle. So we got the brains and the muscle. That what makes the cluster. Okay. Notice the nodes right here. That's how you scale. So if I have 1 billion documents in this cluster right now, and tomorrow I'm gonna have 5 billion documents, well, I could just add more nodes, and without any downtime, I could scale my data. Let's load some data into Elasticsearch and see how it works. Prepared a little .NET app that's gonna load some data. Now, we have 2 types of data in relativity. One is extracted text, which I mentioned already. Another one is called audits. Now, audits are traces, or basically audits of every action in relativity. So, for example, if user goes and updates a document and changes the value for a field, well, there'll be an audit for that, with information about what field was changed, what values in the field were changed, which user, and a bunch of other stuff. we thought that data would be really awesome and perfect for Elasticsearch. We used to store it in the SQL Server as XML, and it didn't give us much value. And what we did, we took that XML data and pumped it into Elasticsearch. That data is very nested, and Elasticsearch handles nested data very, very well. So let me show you just a little bit about the Data API. For those of you who know aliases, anybody know about aliases in Elasticsearch? So just another good practice to use aliases for everything in Elasticsearch, because you cannot rename indexes, you can't really do anything with them later. So aliases are really cool, and we have this concept inside of our Datagate API. It will not let you to write just directly to an index. So as we worked with Elasticsearch and built out the Datagate API, we learned a couple of things. Another important thing is Elastic, being a database, it does have like an internal queue. So if you're gonna keep sending stuff to it, right, the queue at some point can get overloaded, and Elastic is gonna reject it. It's gonna give you queue rejection errors and other errors like that. So for that, we've kind of built in a retry mechanism into the Datagate API, because Elasticsearch doesn't have it on its own. So I'm going to use this unit test as a runner, and I'm going to create a couple of audits. One thing to note here is I'm generating some fake data here, and if you could see, like for the user ID, for example, I'm not sending username, I'm just sending an ID. So just keep that in mind. So that succeeded. Hopefully we've got some data in Elasticsearch. Awesome, so we got 2 documents. I didn't want to load a lot of documents just yet. So let's go ahead and explore those documents. I'm going to log in into another system that Elasticsearch has, or a plugin. It's called Marvel. Marvel is a pretty awesome piece of software. Now, to answer your question earlier about free or not, Marvel, for example, is not free. Okay? But it's pretty awesome because it keeps historical information about your cluster in one place. So you've got the search request rate and indexing rate. It's basically how fast you're getting data out and how fast you're getting data in and data out. Yeah. We've got some cool stats about our nodes. It looks like I'm in yellow right now. I'm running a little bit out of space, but I think we'll be fine for today. I'm going to go ahead and open Sense, which is, think about that as like a SQL Server Management Studio. That's where you execute your queries. Go ahead.
Looks a lot like Kibana. What's the difference between Marvel
Okay,
and
so
Kibana?
the question was, this looks a lot like Kibana, and it is Kibana.
Yeah.
Okay. The Elastic is pretty awesome, and one of the key actual differentiations about Elastic from other things like Solar is it's pluggable. You could plug everything in. They actually built Marvel on top of Kibana.
Nice. Okay. Thank you. Again.
Okay, so let's see what do we have in that index. So we've got, this is a typical Elasticsearch document. It's JSON based, and as you can see here, the data is very nested. Now, since it's very nested, you could easily search it, and you could really dig deeper into those fields. For example, if you want to make a query on the old value right here, or new value, find something, you could navigate to it by like a dot notation, details, that audit element, that field, that new value. And that's how you kind of search Elasticsearch. I'm not going to go into too much details about that, but what I want you guys to kind of note is the user ID. So in SQL Server, we display the names for the users, and the username can change. You could go and like edit the username from Misha to Peter, right? But my ID will not change. So we store only IDs in Elasticsearch. And I'm going to explain why a little later. So let me show you Kibana. So to answer your question. So Kibana is another cool piece of, I guess it's already part of the ecosystem for Elasticsearch. Kibana is a cool visualization tool that acts on your data. Okay. So let's go ahead and use it. So what are we doing? Just trying to find that word. Just first. How many of you guys worked with Kibana? Did you like it? Which version of Kibana?
4.
4? Okay, cool. So as you can see, I built a little dashboard, and it shows me some data about 2 documents that I loaded. Let's go ahead and delete those 2 documents and load more data. It's more fun. Just gonna set it to refresh more often, so we could see some cool real life stuff or real time stuff. So I've prepared another test that's gonna just pump more data into Elasticsearch. So this is gonna happen. Hopefully, soon we'll see a little bit of data here. In the meanwhile, right, here we go. So, as you can see, we've got a bunch of data coming in, and Kibana, can refresh based on the time period. One thing to note here is, for actions and object types and users, these are the properties of my audits. We only have IDs. So if you look at the data from Kibana, you don't really have that much value. I thought it's pretty awesome. My favorite thing is this sub-aggregations. Let me show you what that is. So this thing right here in the bottom, it's very colorful, and what that means. So for example, for the user ID 103, you've got a couple of actions that user was doing. And for each action, you have a couple of object types. So the actions are the types of objects that user was acting on. And you could, get some cool visualizations about that. Any questions about Kibana and Elasticsearch? So now let me jump back into the code. So we've loaded some audit data. Now let's load some textual data into Elasticsearch. So again, I've prepared some unit tests to load some text data. Let's create 2 text documents in Elasticsearch. I'm gonna jump back into Marvel and open up index. So, a couple of lessons learned about storing text. First of all, we do calculate the byte size and store that in Elasticsearch. And the reason why we calculate the byte size is because Elasticsearch does not give you per field size information. It only gives you information about the size of the whole document, but not per field. So that's one thing we kind of build inside of our API to make sure we get the size. Why do we need the size? What do you guys think?
Asking
Yeah,
the cost for customers, how much is based on storage.
Okay, that's one use case. Yes, we want to know how much data you have in a particular field. We'll also have lots of other different use cases for sizing, like streaming the data, because if data is too big, we'll make a decision based on size what to do with it. Elasticsearch is pretty cool. When you write data, that's pretty much the only thing you could do to it in order to insert it. If you want to update the data, all you do is to overwrite the data. So Elastic doesn't really have a concept of update. Rather, you just write the data with the same ID. So I'm going to demonstrate it here. So So on that line, we've got this text, Chicago Quarter Conference, super awesome. I'm gonna change it to this, super mega awesome. And let's see if that's true. It's gonna show up, it's true. It's not. So let's refresh that. As you can see, I just wrote the document with the same ID to Elasticsearch, and instead of creating new one, I actually updated. Okay. Go back. Any questions about text and the sizes and how we use it? Okay. So let's talk about audits. So I just was showing you examples of how we could load audits into Elasticsearch. Now, how do we load audits within our application? So what we do, we first of all did not want to break a transaction between the action and the audit. So when the user edits a document, we want to make sure that that audit goes together with that update. So if audit fails, then we want to roll back the transaction. So all audits first go to the SQL Server. Then we have a process we call migration agents that read SQL Server data and move that data to the data grid. And later, we have the same type of agents, but they're just deletion agents that verify data that was migrated and then deleted from SQL Server. Any questions about that process? How we do that? So let me jump into our relativity environment and show you how we use audits. Again, just remember what we saw in Elasticsearch. We have a bunch of IDs and no names. So what's loading here is the UI for audits. It kind of resembles Kibana, but with a major difference. Now it has names. So that's how we blend the data. Now, let's see how exactly we do that. If you look at this list, you have usernames. If you want to filter that, let's say we will pick the admin relativity. Okay, cool. We got a bunch of data related to the user admin relativity. Now, let's see how that query looks behind the scenes. So what we do, we send the ID to Elasticsearch. We never send names. On the other hand, when Elasticsearch replies with the data, it gives us IDs. And then in code, we merge that data with the SQL Server. Now, that's not a lot of data to merge because everything is paged. So as you notice, this list right here has 25 items per page. So the most we need to merge is 25 records at a time. Now, what's cool about Elasticsearch, Elasticsearch already kind of comes in with the concept of paging. You could tell it, hey, here's a query, give me the first page of that query, and I'll do it for you. Really awesome. Any questions about this, how we merge audits with SQL Server? Again, there's not much to it. It's pretty trivial. Yes?
What about if you're trying to aggregate the entire result set?
Yeah, aggregate. So the question is, what if you're trying to aggregate the entire result? Well, if you look here, we actually have aggregations. So the user actions, we do the same exact thing. So we tell Elastic, hey, Elastic, aggregate the data, give us a bunch of IDs for the user actions with counts. As a matter of fact, we could look at that graph in the tabular format. So from Elastic, what we get the IDs with counts, and then we go back to SQL, merge those IDs with names, and display it to the user. So that's how we do aggregations. Okay. Kind of jump back into the demo. So let's get to the kind of most fun and interesting part, which is extract the test. So imagine this is a table with a bunch of data in relativity. We've got extracted text, and we've got the responsiveness column, all in one view. Extracted text comes from Elasticsearch. Responsiveness column comes from SQL Server. So let me show you how we merge those two together. What's our thinking behind it? So this little diagram will demonstrate the process. So we've got Elasticsearch cluster and SQL Server. What we do, we first query SQL Server to make sure we get the appropriate sorts and all the conditions from SQL Server. We get the IDs and data back from SQL Server and put it in memory. Remember, we don't do it for billions of documents. We only do it for like 100,000 documents at a time. Again, the same paging concept comes into play here. We then take those IDs that we get from SQL Server and send it to Elastic, along with the fields that we want to retrieve. In the previous slide, it would be extracted text. We then get that data back from Elasticsearch and merge it in memory and then display it to the user. So that's how we blend the SQL data and Elastic data for read. Any questions about that? Now, the even more interesting part is search. So here's what we do for the search. We first go to Elasticsearch and query Elasticsearch for the data. Now, when I say search, this is a condition when you have two queries going at the same time to SQL Server and Elasticsearch. So we query Elasticsearch, we get the IDs back from Elasticsearch, and we store those IDs in SQL Server, in the table. Any idea why we do that? Why do we store IDs all the way across the network on SQL Server in a table? Really? This is, we're just talking about like extracting text.
Joins later?
Yeah, exactly. So we want to join the data, and which system is good at joining? SQL Server. So it's exactly what we do. We query SQL Server and join to the table with IDs.
So is that just a temporary table then that you delete at some point?
Exactly. That's a temporary table which has a lifespan of just a search. We then basically follow the process in the previous slide. We then go ahead and read the IDs, by IDs for specific fields from Elasticsearch, get the data back, and merge it. Now, we're still working to optimize the solution. Anyone see any kind of overhead situations that can happen here? So one overhead situation that will happen is that when we get the IDs from Elasticsearch, let's say we get a billion IDs. Let's take it down a little bit, 100 million IDs. Okay. We go back to SQL, we bring all those IDs over. When we join with the SQL condition, we might eliminate 95% of those IDs. So we're bringing lots of IDs, but we don't really need many of them. So we are still exploring options how to optimize, and it's fun. Cool. So any questions about how we merge textual data, extracted text, with SQL data? Any? Go ahead.
What kind of storage do you have for Elastic?
Kind of storage? It just runs in whatever, like a regular file system. Yeah. So Elasticsearch, behind Elasticsearch is a Lucene index, and Lucene index is basically file index. Okay. So you have many Lucene indexes, behind one index in Elasticsearch. Cool. So I think we've got a little bit of time, so I'm gonna jump and show you some user metrics. So what is user metrics? At KQA, we have this cool concept called hackathons. So every couple of months, maybe every 4 months, we get a chance for 3 days to just code whatever we want. Got to be related to a little bit to our software in the industry, maybe. So what came out of that is kind of like Google Analytics for relativity. So what we do, we track every single click that users make in relativity and send that data, guess where? To Elasticsearch. Now, we've made a couple of mistakes with that and learned a lot about Elasticsearch. And first, not a mistake, I guess we just didn't know. We would send a click to IIS, and then IIS would process that click right away and send it to Elasticsearch. So what happened at the end, Elasticsearch got a lot of singular inputs into it, and it could not handle it. There's just so much overhead. So it's another lesson learned about Elasticsearch. Do not send single things to it. Only send bulk things. Send 1,000 things to it at a time. 2,000 things, 10,000 things at a time. And then we changed, and now here's our latest infrastructure. So all the clicks come into IIS, and then IIS has the IIS log, right, that is stored on disk. Then Elasticsearch has this cool, another piece of their ecosystem called Logstash. It's basically a log shipper. So what that does, it looks at those logs, collects them, and in bulk converts them into Elasticsearch documents and sends them to the database cluster. You get almost real-time data. Let me show you a demo of that. Any questions so far about that? So this is an example of how we use user metrics, or clicks from our clients and Kibana. That's all we need. We could make business decisions in that. Now keep in mind, this is just us data in our test cluster. Okay? What we could see the time-based information. Elastic is really good in that. We could see counts. I think. Let me see how many documents I have here. Oh, cool. So we have 25 million documents. Let me filter some data just to show you that it's pretty fast. Here you go. We just filtered 25 million documents in about 2 seconds. My favorite kind of visualization tool in Kibana is maps. So for example, this map right here shows you where those clicks are coming from. Can you guys see that? It looks like Australia, exactly. I was looking at Australia the other day, because I wanted to travel to Australia, and I realized that we don't have a lot of clicks in Australia. So this could be a perfect business decision. Go to Australia, and especially go to places where we don't have clicks, and maybe get some business. This is pretty much it. Any questions before I close up about Kibana?
So the clicks that you monitored there are users searching data. Is that right? Or what are those?
So those. Let me jump back in there. So those circles, right? This is users clicking somewhere in relativity in our software. Yeah. So one of those. Let's actually roll over and see what that shows. So if we roll over, we could see we have 5,582 actions that happen in that region. Now, I'm really excited about Kibana 4.1, the next version. It will actually allow you to kind of like drag and filter based on the map. Okay? Because currently, for example, you could filter on something like this, like relativity version. What will happen, if that happens, yes, so everything will update accordingly. So that's a part of Kibana. You could just like click on one thing and see everything that's related to it. Just take some time. So, click. Any more questions about Kibana? Yeah?
Just out of curiosity, did you guys attempt to use Splunk when
Splunk?
initially starting all this stuff?
Yeah, so good question. Splunk is not free, right? It's an enterprise software that can process logs. It's widely popular. And I think the Elk stack, which is this Elasticsearch, Logstash, Kibana, is a direct competitor to Splunk, many say, and it's free. So why use Splunk when we have Kibana?
Nice.
So, just to recap, we learned a lot about Elasticsearch and Kibana, hopefully. Showed you that SQL Server, well, you already know this, SQL Server is really good for relational data. Elasticsearch is really good for large, unstructured information. Showed you how we merge the two data sources together. And we talked about some clicks. Any questions?